All right, hello there, computer science folks. 3U, the big day today. Big day. We start getting the computer to do something pretty awesome, which is this idea of a loop or repeating the same process over and over again. Computers are awesome at this. Uh, and up until this point we've seen computers are pretty awesome at doing exactly what we tell them: statement then statement then statement. If we mess up the order, the computer is just going to do it statement. There's also the computer is very good at doing comparisons, right? And that was that if business, and the switch structure also worked. And now the computer is also very good at doing the same thing over and over again without thinking about how boring it is. And today we're going to talk about counted loops, or for loops is what it is in most languages, called for loops. A for loop executes a specific number of times, a counted number of times. And here's oh, by the way, I'm using Smart Notebook for no particular reason. Probably if you used WordPerfect or Google Docs or whatever, all will be fine. So I'm using Smart Notebook for no reason here. Um, Syntax. The syntax, that's not spelt right. Well, there, syntax. I guess that's why I'm using Smart Notebook, so I can correct my own typing. Um, Remember, the syntax, when we do these notes, it's kind of like, what does it look like in general? And it starts with the word for, and then these words, by the way, take the place of Java statements, and we'll talk what initialization. Well, we know what initialization means. That's when we start with a. You don't have to write this part down, but if we start, um, that's a declaration. That part there is an initialization. It gives the number variable an initial value. And again, you don't need to put that down, but that's what initialization is. Condition, well, we saw conditions when we were talking about ifs. An increment, well, that's going to be a new little animal that we'll have to talk about. But each for statement has these three things in round brackets, and then it's got a set of curly brackets like that. Notice no semicolon here, right? The curly brackets take the place of the the semicolon. And it says these statements will be executed as long as condition is true. All right, so I'm going to go to ready here, and I'm going to open a new HSA. I'm just going to call it for loops note. Um, you don't necessarily need to do this. You're welcome to. And I'm going to actually uh, put in something here. So for, and notice it's a keyword, so it went black. Initialization. So the initialization is int. I'm going to say counter maybe equals 1. So it's going to start at, the counter is going to start at 1. And I'm going to say this is going to keep going as long as counter was less than or equal to 5. Okay, and the increment is a weird thing. That we need counter to go up, right? And the idea is we're going to get the counter after the loop to equal the old value of counter plus 1. All right, and I know that's a weird statement. This is what the increment statement looks like right here. This is the increment statement. And that doesn't make any sense mathematically. I'm going to go back to my note here. We'll go back to the program and see what's going to happen here. But if I have that statement, it doesn't make any sense in math, right? We go, all right, in math, subtract counter from both sides, 0 equals 1, and very confusing. We don't know what's going on. This is computer science. So remember, what happens in computer science is the left-hand side of a statement, that's the memory, right? That's the memory. On the right-hand side is the calculation. So it's going to look this up in memory, get a value, it starts at 1, and then add 1 to it, do that calculation, and that means the new memory, the spot in memory for counter is going to become 2 after it does this calculation. So this is the increment. And don't worry about writing this down. We will get it into our notes. Don't worry. And it looks strange, but don't be scared. Where are we? Right there. Don't be scared of that. So here, what's going to happen is this should, oops, execute these statements as long as this condition is true, as long as counter is less than or equal to 5. Well, what would that mean? It would mean, well, when it's 1, when it's 2, when it's 3, when it's 4, when it's 5, is it less than or equal to 5? Yeah, so this should execute, and then it increments to 6 and then poops out there. It should execute this command 5 times. So let's go c.println hello world, and this should run 5 times. Let's have a look. 1, 2, 3, 4, 5. Yep, dandy. And that makes sense, because what happens is it does the initialization only once, and then it starts into this condition. Is counter less than or equal to 5? Well, when counter is 1, indeed, it is less than or equal to 5. So that means it's going to execute this statement. It gets to the end of the loop, then it goes up and does the increment. So then counter becomes 2, right? The old counter was 1, and then it adds 1, that becomes 2, and assigns it, and then it does the condition. It checks this condition. Is 2 less than or equal to 5? Yes, it is. And so then it prints the second hello world. And then it gets to the end of the loop, goes back up, increments, checks the condition, prints it out, gets to the end of the loop. And notice these loops could have many, many statements, whatever we want in here. Increment, check the condition, and then at some point, right, when this was 5, 5 plus 1 becomes 6, and then is 6 less than or equal to 5 anymore? As soon as that's false, it clunks out, does not execute the statement, and then goes to the end of the loop. Okay? Great. Well, let's do a more interesting example. So instead of just printing out hello world, let's do the rest all's lunch program again, just for funsies. And I'll get back to the note shortly here. So for instance, let's go print, please enter lunch amount for day. And notice, I can use this counter in my statement, right? So that's going to be day 1, please enter lunch amount for day 1, day 2, day 3, at every time it executes. And then I'm going to make it look like a little, oops, a little prompt here. This is a little symbol for a prompt. And then notice that looks okay. And then it's going to prompt for, let's say it prompts for the amount spent. And that's going to be a double. Notice that I need to initialize that variable amount. That's a double. And then I'm going to start adding it up. So I'm going to have another value called total, which is also a double. Instead of having 5 variables, I can reuse these variables over and over again. So what I want to do is I want to add to the total the new amount. So I got to take the old total and equals or plus the amount. All right, so what this statement does, this adds up the amounts. This reads in new amount, and this adds it up. So the idea is whatever total was, I get the user to add, enter an amount, and then it will do that calculation and then store it in total. Now, if I ran this right now, I would get an error. This is giving me a runtime error. Watch this. Okay, the variable total may be accessed here before having definitely assigned the value. So even though I declared it here, it can't find a value for total, so it can't do that calculation. Well, if it needs a value to start, this is why we should initialize all of our variables. We're going to let the total be 0 to start, and then that should work. Please I'm going to get rid of this thing here. What's this here for? So 6, 7. I'm just putting in a bunch of data here, and notice how clear those prompts are. And it didn't print anything out yet, but that's because I need to add that to my C dot print line. Your total was, oops, your total was plus total. And that's going to add all those up for me. And notice that I only have those 2 variables in the counter. That's going to be lovely. Now, in a second, I'm going to come back and copy this into my notes so I have a good example in here. But I want to mention some of these things that I had already talked about for my note. So this is back to your note now. This first line, initialization, sets up the counter for the loop, and that was, for instance, int counter equals 1. That would be in the place of the initialization. So that part there is this part there, and you don't have to write this in green or whatever. The condition, remember, is to check to see if the loop should be executed again. And remember, that's counter is less than or equal to 5 in the example. That one, that was this, just to be clear here. An increment is the statement that changes the counter, and that's that counter equals counter plus 1. And that was that weird statement we talked about where remember the right side is a calculation, the left side is a memory assignment. Okay, great. What I want to do is now I'm going to grab, that was my rough notes here. I'm going to get rid of that. I'm going to go back to my note, my program rather, and I'm going to copy this so I have an example. For example, I'm going to copy this. Hopefully it looks nice. Oh, not bad. Not bad. Make it a little smaller so I can read it. I want to read this all at once. That's not beautiful, but oh well. Dandy. Now at least I can see some of it. Notice there's lots of blank spaces in here. It's not the font doesn't look great. If I wanted to change the font so it matches ready, remember the font is Courier. Right, so if I change this to Courier, it'll look nicer. Well, not nicer. It'll look more like ready. Yeah, dandy. And now I've got my example. Okay, some notes about this example. First of all, that adds up the amounts, reason in the amounts. This statement here, counter equals counter plus 1, we often short form that. There's a short form that's kind of nice. Counter plus plus is a short form for counter equals counter plus 1. They execute very, very similarly, and if you see that in Java, that will be the same calculation as that. Similarly, that line total equals total plus amount plus equals amount is a short form for total equals total plus amount. Okay, so those are two short forms. The more short forms you use, the harder your program is to read. This is sort of easy to understand what it means, and until we get used to it, this looks difficult to read. This, yeah, okay, I can kind of understand that. I'm going total plus amount and assigning it into the variable spot total. I can handle that. Um, but when you see that, it looks confusing. But you'll run into examples where these things are used. Um, in the second part of the video here, I'm going to run through this code and or what's called a walkthrough or a trace of this code to show you exactly what the computer is doing. Okay, and I'm going to do that in part two.